Good morning, everyone, and welcome back to this week's video. I hope everyone had a great time learning about forces last week. Before we jump into today's lesson, I want to do a big thank you to all of those of you who sent pictures of your domino setups from last week's video. And a special thank you to Paul, Diana, and Armante, who sent videos that we're going to check out now.
The video, Mr. Gilbert, that you want us to do.
Again, I really appreciate everyone taking the time to show their example of forces at home this week. Today, we are going to return to our discussion of matter. Do you know what air, water, and an apple all have in common? They seem to me like they're very different things, but they are all examples of matter. Matter is a word that we've used a lot this year in science. It means stuff, for lack of a better way to say it. All of the stuff in the world that has mass and takes up space is called matter. When we think of an apple, that is an example of a solid. Water is, of course, an example of a liquid, and air is an example of a gas. Look around the room where you are, and I want you to see what other examples of matter you can find from where you are sitting. Today, our focus on matter is going to be about its properties. We can see on the screen physical properties of matter are the look, feel, taste, sound, or smell of an object. The matter that you saw in the room around you has many different properties. These properties help us to describe and to compare the different types of matter. Think of properties as ways of describing the things around us. Look again at those things that you just saw in the room around you. Are they big or small? Are they hot or cold? Or maybe even heavy or light? Let's look at some other basic properties of matter that we're going to talk about today. The first one is its mass. An object can contain a lot of matter. For example, if you had a brick, or it can contain very little matter. For example, a feather. The brick has a lot more mass than the feather, even if they were the same size. Volume is the next one. Matter can take up a lot of space. For example, think of all of the water in the ocean, or it can take up just a little. Think about a snowflake. The ocean has a much greater volume than the snowflake. And the last one we're going to look at the moment is temperature. Matter can be very hot. For example, lava flowing from a volcano, or it can be very cold. Think about ice in a glacier. Of course, the lava has a much higher temperature than the ice. It is important to remember that some matter can be difficult to observe. For example, we sometimes forget that air is matter because it is invisible and hard for us to feel. Even though we can't see the air, it takes up space. Have you ever blown up a balloon? You blow into the balloon and it starts to get bigger and bigger. As the balloon gets larger, that's our evidence that we can use to show that air really does have a mass. It's made the rubber of the balloon expand bigger and bigger. Another thing to remember is that not all solids are hard solids, like a table or a brick. Some solids can be soft. Think about the clothes that you are wearing right now. Are your clothes a solid, a liquid, or a gas? Even though something feels soft and moves around, it is still, or can still be, a solid. And our clothes are a great example of that. Now, how do we measure matter? There are many different ways that we can measure matter. Let's return to our example of an apple. The apple can be weighed on a scale. We could use a ruler to measure the height and width of the apple. But now what about volume? How could you measure how much space the apple takes up? What if you had a container filled with water and you set the apple inside? You could measure the amount that you could measure the water level before you put the apple in and after, and see how much it has risen with the apple in the water. This might seem kind of silly, but we could also take the apple's temperature using a thermometer. Not that we would ever do that. Now, how about comparing matter to other matter? How would we do that? In order for us to do that, we must ask some questions that will help us to think about the matter, and we are going to call this classifying matter. Our definition we see on the screen is to identify groups of similar things. We're going to ask these questions, and we're going to put things in groups based on the answers we get. So the first question that we're going to ask today is, what is the object's state of matter? Is it a solid, a liquid, or a gas? The second question is, does the matter sink or does it float? I want you to take a moment and think about how we could do that. Of course, we've mentioned in class at some point during the year that we would just put things in water. If it stays on top, it's floating. If it goes to the bottom, it sinks. And our last question, is the matter magnetic? We would, of course, use a magnet to help us determine whether the magnet will attract the object or not. So now we are going to do an activity where we are going to work to classify some different objects by answering those questions. So I've collected these objects to use in order to for our investigation on classifying matter. We have a soda can. This one is empty. We have a quarter, a small rock, a golf ball, a toothpick, a pencil, a nail, a paperclip, and although it looks like an ear, this is an eraser. So the first thing I want to look at, or the first property of matter I want to look at, is its shape. Do any of these objects look similar in shape to you? To me, the toothpick, the pencil, and the nail all have a similar shape. They're all long and skinny. The golf ball and the quarter are both round. The other objects, they don't seem to have too much in common in terms of their shape, so I don't think that we can group them together for this property. Now, what about their material? The pencil and the toothpick are both made out of wood. The nail, the paperclip, the coin, and the soda can are all made out of types of metal. So we could group those different groups together. Now let's take a look at if any of these objects are magnetic. Of course, we have the same magnet that we had from last week, and we are going to test. So I want you to take a moment, look at all of these different objects, and think about which of them do you believe will be magnetic. Remember our properties of magnetism that we've studied before? What do you think? Let's go ahead and test. Does anyone think that the golf ball will be magnetic? Nope. Golf ball's not magnetic. So we have the wooden toothpick. Did anybody say that was going to be magnetic? No. About the wooden pencil. Even with the lead inside of it, it's not magnetic. What about the rock? Oop, we got the paperclip. Didn't mean to grab that, but obviously that metal paperclip, we'll add that to our list of magnetic objects. The rock, on the other hand, nope. What about the coin? It's metal, so will it be magnetic? No. And what about the can? Again, it's metal, so will it be magnetic? No as well. So as we discussed before, not all metals are magnetic. We have the ear, the rubber ear, eraser, nope. And finally the nail, I'm sure you guessed that that will be magnetic. And our last test for today will be to see if these materials sink or float. Let's put it back over here. There we go. All right. So again, thinking about these objects, which ones do you think will sink and which ones do you think will float? We can use our knowledge of things in everyday life to answer this question. Are things that are wooden, or do things that are wooden generally sink or generally float? Let's check. The toothpick, definitely gonna float. What about the wooden pencil? Definitely floating. What about the rubber eraser? Does rubber sink or float? This eraser has definitely sunk to the bottom because it is more dense than the water. So let's put floating ones on this side, sinking ones on that side. The nail, I think we should know what that one's going to do. Of course, that one's going to sink. The quarter, if you've ever thrown a coin into a fountain, you of course know that one's going to sink. A rock, if you've ever gone to a pond or lake and skipped rocks, you know that while it'll kind of skip along the water for a little while, in the end, it will sink to the bottom. The paperclip is very light, does not have a lot of mass. Will it sink or float? And it sinks. A golf ball. If you've ever hit a golf ball into a lake, like I have, it's definitely going to sink right to the bottom. Now what about the can? It's metal. All of our other metal objects have sunk. So what do you think about this one? It's going to sink or float. Because the can has very little mass and all of the air inside of it is less dense than the water. So that's actually going to stay on our floating side. Now, just for one more test, I have an unopened can, the same kind, same size. An unopened can has a lot more mass. Let's see what this one does. This one, I know you can see a little bit of the can here sticking up. So it's sinking, but not all the way to the bottom. It's partially sunk, but partially floating. So the mass of the can is the density of the can is more similar to the water than the other objects. It's kind of in between. It's not a lot more dense and it's not a lot less dense. It's in between, so it's partially floating. You can see it bouncing in the water there. Alright everyone, that is it for this week's video. Thank you again for taking the time to watch. I hope everyone has a great weekend. Make sure you take some time to check out the activities online on STEMscopedia and work through those. And I will look forward to seeing you next Friday. Bye everyone.